power, we would rewrite this as u to the 13th. Would you agree? And then I'd say, okay, now let's take a derivative. That's what d dx was. And you would say, okay, well, that would be 13u to the 12th, but we'd have to attach the chain. And what was the chain?
The derivative of inside the parentheses.
The derivative of the u.
Yeah.
This was the derivative of that, correct? Or another way to write u prime, we didn't write it this way, was du dx. Okay, that was another way to write it. Are you with me? Are you following along with me?
Yeah.
Okay? So if then I'm like, okay, now I'll rewrite it as 13. My u was 3x squared plus 5 to the 12th power. And then what is the derivative of what's inside? 6x. And you were very happy and you knew how to do that. When you first learned it, you're like, oh, this is difficult. No, it's fine. You were fine. Well, now we're going to be given, listen.
Are you okay? The peanut butter came to him. No, it was the lifesaver from it.
Okay.
I was getting scared.
I was getting scared too. Okay. Well, now you're going to be given this. Listen. And you are going to have this little symbol in front. And you have to rewrite this symbol back to that. Well, what I want you to notice is there must be a u in the problem. Wouldn't you agree? That was the u? That was the u over here?
Yes.
Okay? And do you all agree that not only was there a u in the problem, listen, focus, there was a derivative in the problem of that guy. Okay? So flow with me. You're going to be given this. I know this seems silly in kindergarten, but you've got to pay attention because this is what we do as mathematicians. We look for patterns. We know that this must be the u and its derivative must be inside. And that's what the whole key of what you're going to do today is going to be about. Look for a u, look for the derivative inside, and then you can write it backwards. Okay? So in calculus terms, what you're doing is you're looking for this u and its derivative, we call du dx, okay, with respect to x. Well, those would cancel, and you would have an integral of u to the n du. Now, stop right there and listen, okay, because this is notation, and a lot of people get scared of notation. If you can make your problem look like this, with u's and du's. This is your job. On homework today, it's a game. The game is find the u, find the derivative in the problem. If you can make it look like that, then you can apply the power rule. And the power rule says u to the n plus 1 divided by n plus 1 plus c. That's the power rule we've been working on. Okay? So let me go through this one more time, and then we'll do an example, and I hopefully you'll all grasp on. Your job is to find a u to a power, to find the derivative inside of it, and then once you do that, once you write it with u's and du's, you can then apply the power rule. Okay,
So,
go ahead.
what's the point of applying the power rule?
Because again, we're trying to get back to here. We're trying to get back to the original function. We want to go back to what it was.
Just like playing around.
We are trying to, your job as an antiderivative is to get back to an original function, and we need to know the original function. So
We already know the original.
we don't know the original function when we're given just this.
Oh.
We don't.
I thought you were saying they're going to give us that. We have to find that.
No,
and then
no,
we
no,
have to
no.
go back to that.
Yeah, no.
What's the point?
Okay, write this down. You must, so this is the whole gist of what I was just saying. You must identify a factor of u raised to a power. So that's the first thing you're going to look for. Find that factor of u raised to a power. Sometimes it looks like it's raised to a power, sometimes it isn't. You also need to show that its derivative, is also a factor in the integrand. Okay, so that's the two big big picture idea of today. We're looking for the u, we're looking that its derivative is inside of it, and then we can write it backwards and go to what the original function was. So we'll start off with 2 examples. We'll work through it. And like I said, if you get lost, you kind of need to just keep going on the train, and then I'll talk to you about it afterward, because that's what we do. No.
Yes, do that.
Thank you. Now, again, for all these problems, you could FOIL every single one of them out and then take the integral of each one. That would be stupid, okay? It would be like foiling this to the 13th power. Why would you do that? Okay, so you've got to practice the U-substitution method that we're about to learn, and especially if you take Calculus 2, it will help out. All right, so right now I'm pretty sure most of you could probably figure out which one we're going to call the U.
3x.
Okay, so on the side of your paper, you're going to write U equals 3x minus 1. So watch what I'm about to do. I'm going to replace this with U to the 4th. Do you all agree? Okay, now I'm going to take a derivative, we're going to call it du dx, of my u. With respect to x, that's what the dx is, and it's 3. Well, I'm going to multiply this side by dx and this side by dx. You'll see in a minute. And I end up getting du equals 3 dx. Would you all agree to that, right? Just dx on this side. Well, look what I have here. I have a 3, and I have the dx. Well, that is the derivative of the u that I'm going to now call du. This 3 dx is du. 3 dx, are you with me here? Okay. And if I put the integral right here, what I've just done is I've played the game. I made this look like u to a power and a du. U to a power and a du. Once I make it look like that, I can now take a power rule. And what does the power rule say to do with that 4? Add 1, so you get u to the 5th over 5 plus c. And then guess what you can replace it now with? 3x minus 1 to the 5th over 5 plus c. That was the original function. If I take a derivative of that, I would get this. Okay? So, again, the game that you're playing, let me say it again, I'll say it a couple times, is you can only have, inside the integral now, u's and du's, unless you FOILed it out. You can only have u's and du's. You cannot do it unless you FOILed it out. All right? Let's do this again, because the more you practice, the better you'll get at it. Okay? Now, I don't see anything raised to a power. You could FOIL this out and then take the integral of each one. Totally could. But I want to practice the u-du method. So take a derivative of this right now in your head. What would that be? 2. Take a derivative of this in your head.
2x plus 1.
That's the derivative of that. So which one do you want to call u then?
X plus x.
All right, so let's call u x squared plus x. So this right here, I'm literally going to replace it with u. Okay? Du dx, I'm going to call 2x plus 1, but I'm going to multiply both sides by dx. Eventually you won't have to do that, but we're doing it right now just to show you. And isn't that what this is right here? So I can, now I'm just literally replacing that with du. And then I'm bringing down my integral. Oh, look at that. I have a u, I have a du. Once you have it written with u's and du's, you may apply the power rule. So what does the power rule say for this? What would be my power rule? What would I finish it off by saying? U to the what? Second.
Second over 2 plus c.
And then just replace your u now with x squared plus x. Okay? How are we feeling?
Where did we get,
As of right now, it gets a little harder, but it's not that bad.
Where did we get u squared over 2 plus c?
Because the power rule says, right, this is to the 1, add 1, divide by 2. That's the power rule. Add 1, divide by, it's been what you've been doing now for past couple of days. This is on the quiz 3.4. Yeah, 3.4. All right, next one. We've got 9 to do, and if you keep interrupting me, I'll keep you till lunch. That's right. It's my job. It's a great day. Number 3, integral of 3x squared times the square root of x cubed minus 2 dx. Let's write another one right here. Negative 4x times 1 minus 2x squared dx. Might as well write another one. I'll give you a minute to write these out, and then we'll do... You have to practice this method, and especially like this one, you can't FOIL this one out because this is raised to a power of 1/2, so you can't really FOIL it out. It would be very difficult if you tried to, okay? But we can practice the U method. So let's go here. What would I call my U?
Probably the thing is.
Right, so what do you agree? This would be like U to the 1/2 right there? Okay, so my U is x cubed minus 2. I'm just going to call it du, and I'll put the dx on this side. Take a derivative. Put the dx on this side. Don't I have that in the problem? Super nice.
Is it always gonna work out like that?
No, but I will show you example of when it doesn't. So then this, what I'm crossing off and replacing it with du, and now it's an integral in a power rule form, and I can just add 1. What do I do? Well, 1/2 plus 1 is divide by 3/2, which is multiplying by the reciprocal, so 2/3 plus c, and then all you have to do is replace the u. So 2/3 x to the 3rd minus 2 to the 3/2 plus c. That's the last one that'll be as easy as it looks right now. Actually, no, I take it back. The next one will be, yeah.
What's the point of finding the du if we're not gonna...
Again, the point is, your job is you have to make sure the derivative is in the function because that's how the chain rule was. The chain rule said you better attach that chain. And so you have to find the chain now. That's what you're finding. That's what du is, the chain. All right, let's do this again one more time, and then we'll do a harder one. What do you think my u is here?
1 minus 2x squared to the negative second power.
No. It's just the 1 minus 2x squared, okay? But it's on the bottom, okay? So we're just going to keep it on the bottom right now. We're going to take a derivative. What is the derivative of that? X dx, which is located right here on the top, yes? Okay. If you are on the top, what I like to do is bring it to the side, yes? And this is 1 over, because anytime you bring it to the side, and the 2, like he said, was on the bottom, and then Sammy had already brought it up for me, which was great, okay? This is u to the negative 2 du. That is u to the negative 2 du. And now you just do the simple power rule, which would be add 1, divide by the new exponent. So if I added 1 to this, u to the negative 1, divide by negative 1 is negative, and then add a c. Rewrite that for me correctly. What would be the final answer? Dividing by negative 1 is a negative 1, yeah. Negative 1 minus 2x squared to the negative 1 plus c. You know I don't like it written that way. Yeah, so negative 1 over 1 minus 2x squared to the positive 1 plus c, or just leave it like that.
Do you not distribute the negative across the bottom?
No. You could, because it's to a power of 1 on the bottom, you could distribute the negative top or bottom, actually. You could, yeah. Okay? So again, most of the homework tonight is going to be like this. The derivative's in it. The derivative's already there. Oh, the derivative's there. You're just getting rid of it and looking for it. But then you're going to have a problem like this. Okay? All right, so write this one down. We're going to do it right now. Okay? Would you all agree? Again, this is my u. Okay? I'm going to put squared. So 3 minus 4x squared. I'm going to take a derivative of it, which would be what? Negative 8x dx. Okay, whoa, we got a problem here. I don't have negative 8x dx. But I do have x dx. Constants are never a problem in calculus. Constants, we can divide them out or pull them out or do anything. We don't have to worry about it. So, but watch what I do. I'm going to divide this by negative 8. Both sides, because whatever you do to one side, you have to do the other. I now have x dx. But what does it equal? Well, it equals, look, negative 1/8 du. Are you with me on that? So this right here, this x and this dx equals negative 1/8 du. That and that, x dx, look what I wrote, x dx, negative 1/8 du. Are you with me?
Yeah.
I am then allowed, because this is a constant, I could put my integral right there. Because there's a rule, again, if you don't remember, I'll write it here on the side, that said when you take the integral of a constant, you can actually take that k on the outside, that constant on the outside, and then integrate it. So now, this isn't hard, because again, just ignore that negative 1/8 right now, add 1, what do you get? U to the third divided by 3, but then guess what you're going to do with the negative 1/8? Multiply it, and then add c. So write it out for me correctly. What would it be? Let's see. Negative u, which is 3 minus 4x squared to the third, over, what's 8 times 3? That's how you handle when you don't have a number that's not in the problem. Numbers are never a problem.
We have to add.
You have to make sure, though, you had that x dx covered. You can't have x's. You can't have dx's. You can only have u's, du's, and numbers. That's it. Okay?
Are we supposed to add the negative 1/8? It doesn't matter.
Never add the negative 1 and multiply the negative
I mean,
1.
you know what I mean? Like, you didn't write it.
I multiplied it in. Yeah. All right?
I'm sleepy.
That's okay. Let's do another one like that, and then we're almost done with the last x cubed times 3. Okay. Same idea. Tell me your u. Tell me your du. Go ahead. Tell me your u. Tell me your du. Oh, no. You just do it. Just do it. Just du it. Oh, okay. Thank you. Thank you. I'm here all year. I wait all year for this. My great math jokes forever.
That was solid.
Thank you. Thank you.
Lurched it, man.
Lurched it up.
Oh, okay. Which did
Yeah,
not-
obviously. Saved it a little bit better. We knew that, buddy.
What am I going to do with that 12? I'm divided out, so wouldn't it become 1/12 du? Equals x cubed dx. Wait a second, I got an x cubed dx. I'm going to call that 1/12 du. And this guy I'm going to call u squared, and I'll put my little integral right there. Okay, and then what am I going to do? Well, now I can do the power rule. Once you have u's and du's and numbers, it's easy. You could just do the power rule, which is u cubed divided by 3, multiply by the 1/12 on the outside, and then add your c. But then obviously you got to replace it to be what?
4 plus 1 to the third
Over 36, right? Mm-hmm. Good job, guys. How are you feeling? This isn't bad, right? It's not terrible? All right, last 3 problems, we're done.
Oh, you got it divided.
You want to miss the last 3 problems, which are probably so important. Go. No, you can go. You have to watch the video. Watch the video. Watch.
Wait, so what was the answer? I'm sorry.
3x to the 4th plus 1 to the 3rd over 36.
You said there's no.
Yeah. All right. last and final couple of ones that we're gonna do here, and it'll be over. Okay, so again, looks like this might be my u, 3 minus 4x squared. I take a derivative, negative 8x dx, okay? Well, look at what I got. I don't have an x. I have a negative 8 and a dx. What tends to happen is students think, oh, look how smart I'm being. I'm going to divide by x. You're not allowed to. You are not, listen to this, you can't have any x's at all in your integration. So when this ends up happening, like you're like, I have the negative 8, I have a dx, but I don't have that x, there's nothing you can do. Actually, the only thing you would have to do is FOIL. You would have to FOIL this out and then integral each one separately, okay?
I still don't understand what's.
Where is there a negative 8x dx? I have a negative 8, I have a dx, I don't have the x, all right? So just because of time, you would FOIL this out, 3 minus 4x squared times another 3 minus 4x squared, and then multiply by an 8 through, and then you take each one individually, which you always can do, but it's kind of annoying. I just want to let you know it is going to happen on homework tonight. But the final answer is this, just for your benefit. 128x to the 5th over 5 plus c. That would be if you FOILed it out. I wanted to show you that because it happens, and students are like, I don't know what to do. I'm like, just go back to what you were doing a couple days ago. FOIL it out and take a derivative, antiderivative of each one. All right? But the next two will work, so we'll go through these and be done. Okay? So, once again, what's my u? I take a derivative and I get, okay, stop, look at it. I have a 7. But do I need to worry about constants? Because couldn't I have just taken that 7 on the outside?
Take it outside.
I can.
Yeah.
So I'm just going to take Mr. 7 on the outside. But then over here, now I don't have the 7, but I do have x squared dx. But, well, that's easy. I can get rid of the 3. So 1/3 du equals x squared dx, which is what I have right here. Do you see that?
Yeah, I do.
So where should I put the 1/3 though? I could put it on the outside and multiply it, correct? And then what would I rename this? U to the what power? U to the 1/2. Now everything has the constants on the outside, the u and the du are on the inside, and now I can do the power rule. This is the game you're playing, guys. It's a game. Find the u, find the derivative u, and put all the numbers on the outside. If you can get it written like that, you can then do the simple power rule, which says add 1. So u to the 3/2 divide by 3/2 is multiplying by 2/3. And then what do I have over here? Times 7/3, and then plus c. And then obviously replace it and clean it up a little bit better for me. 14/9 u to the 3/2 plus c. How did you feel about that? So again, if you end up with 3x squared, but you have a 7x squared, take the 7 out, divide out the 3. Constants are not a problem. X's are problems. Constants are not. Okay? One more. Right? One more. Phone people are driving me crazy. I'm about to throw you out. Throw you all out. What's my u? What's my u? 4x squared plus 2x. What's the du? Stop and look what you have.
Still right. Perfect.
Oh, wait.
Do you see it?
Gotta divide by 2.
Divide by 2.
Wait, don't you take out
Isn't this and this,
2 will go in the
isn't this related?
Well, yes.
If I times this by 2,
Oh.
and I times this side by 2, I'd get 16x plus 4, which is what I have. I can do that. So this is 2 du. This is my u to the 3rd. And I'm going to put my little integration right there. And now do the power rule for me and finish this off, please. Your final answer should be 4x squared plus 2x to the 4th over 2 plus c. This is the game you're playing. Your game, again, should you choose to accept the game, I am the game master. Yes, I am. Again, your job, does it not say master's degree? No, Case covered it because he thought his was better than my master's degree. His 100 on a homework quiz was better. More powerful, I guess. Guys, again, look, one more time. Your job is to find the derivative inside, write it with u's and du's. Once you write it with u's and du's and numbers on the outside, you can do the power rule. It's very easy. So homework is on Canvas, page 335, 10 to 36 even, and number 40. Okay, yes, dear.
Can't you just take out for that last one? Can't you just take out 2?
You could factor out a 2.
And then, because that would go in the front.
But how is that going to help you find the 16x?
Well, what I mean is,
Hold
what do you mean? Well, I'm saying, no, if you take out a 2 from 16x plus 4 from the original.
Oh, yes.
That would go to the
You could
front.
do it. You'll get the same answer that way also. You are correct.
Because that would